Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, can't talk today, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All righty. So today we're going to start the last chapter in this course, which is chapter 11. And we're going to begin with section 11.1. And we're going to talk about an operation like multiplication, division, addition, subtraction. Only this operation is called composition. So we've got composition. All right. Now, the notation for the operation composition looks kind of like a circle. So let's say we're going to take F composed with G of X. It looks like fog, but it's actually F. Then that little circle means composition. So F composed with G of X. All right. Now, how does composition work? Well, you start on the inside and work to the outside, or I should say you start at the right and work to the left. So F composed with G of X is the same as taking F of G of X. Now, I'll go through many examples here, but the process isn't difficult. The difficulty lies in keeping track of what you're supposed to do and in what order, okay? Let's say, for instance, that we have the following situation. We're going to let F of X equal 2x plus 1, and G of X is going to equal x squared minus 1. It says find each of the following. All right, we want to find F composed with G of, oh, excuse me, I wrote that incorrectly. F composed with G of 2, okay? So that means that we want F of G of 2. So we're going to start with G of 2. We're going to go over here to the G of X function, and we're going to find G of 2. G of 2 would be 2 squared minus 1, which is 4 minus 1, which is 3. So now we're going to substitute that back here for G of 2. So F composed with G of 2 equals F of G of 2 equals F of 3. Where did I get the 3? G of 2 was equal to 3. So now I'm going to find F of 3. So I'm going to go to the F of X function and put in 3. Which is 7. So F composed with G of 2 equals 7. Any questions on this example? Okay. We're going to take a look at another example. We're still going to let F of X equal 2x plus 1 and G of X still equal to x squared minus 1. Now we're going to find G composed with F of negative 3. So notice it's G composed with F as opposed to F composed with G, like the last one. Well, G composed with F of 3, negative 3, excuse me, is G of F of negative 3. Well, let's see, this is F of X equals 2x plus 1. F of negative 3 equals 2 times negative 3 plus 1, which is negative 6 plus 1, which is negative 5. So f of -3 is -5. So that's going to go and substitute in the place of f of -3. So now I have g of -5. Well, I'm going to take that and go up here into the g of x function. G of -5 equals -5, the quantity squared minus 1. 25 minus 1, 24. So g composed with f of -3 equals 24. So we're just evaluating functions at different values, but in a certain order. We get the answer to the first one, and then we evaluate the second one at the answer to the first one. Let's see here. How about this one? Again, we're going to use f of x equals 2x plus 1, and g of x equals x squared minus 1. Now we're going to find f composed with g of 2x. So that means we're going to put 2x in the place of x. So f composed with g of 2x equals f of g of 2x. All right. So over here, g of 2x would be 2x, the quantity squared minus 1, which is 4x squared minus 1. So that's going to go in the place of g of 2x. So now we've got f of 4x squared minus 1. So now we're going to evaluate that in the f of x function. So f of 4x squared minus 1 equals 2 times the quantity 4x squared minus 1 plus 1, which is 8x squared minus 2 plus 1, 8x squared minus 1. Any questions about that? A little trickier to follow here, but again, we evaluate g of 2x, we get the answer, we plug that back in, evaluate f of that, f of 4x squared minus 1 to get our final answer. So there's a specific order that we do things in. Okay, let's see here. Let's do some more examples, but with a different set of functions. Let f of x equal 3x minus 2 and g of x equal x squared plus x. Let's find f composed with g of 4. So that's equal to f of g of 4. G of 4 is 4 squared plus 4, 16 plus 4, or 20. So that's going to go in there. So now we're going to get f of 20, which is 3 times 20 minus 2, 60 minus 2, 58. Okay. Let's see. Let's use this same one again. F of x equals 3x minus 2. G of x equals x squared plus x. Now, let's find f composed with g of x. Careful now. This is equal to f of g of x. Well, g of x is just going to be x squared plus x, right? But all of that is going to go in the place of that. So now I've got f of x squared plus x. And that's going to go in here. So that's going to be 3 times x squared plus x minus 2, which is 3x squared plus 3x minus 2. So there's f composed with g of x. Any questions about that? All right, let's look at some that are a little more tricky to deal with. let f of x equal 1 over x and g of x equal 1 over x squared. Let's find g composed with f of 1/3. So that's equal to g of f of 1/3. Well, f of 1/3 is 1 over 1/3, which is 1 divided by 1/3, which is 1 times 3 over 1, which is 3. So 3 goes in there, and now we have g of 3, which is 1 over 3 squared, or 1/9. Any questions on that? Okay, let's take a look at this one. Again, f of x is 1 over x, and g of x is 1 over x squared. Let's find g composed with f of 8x. So that's g of f of 8x, but f of 8x would be 1 over 8x because we're putting 8x in the place of x in the f of x function. Okay, so now this goes in there. So we've got g of 1 over 8x, which is 1 over 8x squared, which is 1 over, let's see, that would be 1 squared and then 64x squared, which is 1 divided by 1 over 64x squared, which is 1 times 64x squared over 1, which is 64x squared. Again, what we're doing isn't difficult, but you got to do things in the correct order. You evaluate the second one, get the answer, use that, and evaluate that at the first one. Okay, how about this? H of t equals the square root of t plus 3. K of t equals t minus 5. H composed with k of 18 would be h of k of 18. K of 18 is 18 minus 5, which is 13. So that goes in the place of k of 18. So that would be h of 13, which is the square root of 13 plus 3 is the square root of 16 is 4. So h composed with k of 18 equals 4. Questions there? All right, so we talk about composition as an operation, just like we've got multiplication, division, addition, subtraction. Multiplication is commutative. You can multiply 3 times 7 and get 21, or 7 times 3 and get 21. Addition is commutative. 7 plus 3 is 10. 3 plus 7 is 10. So then the question is, what about composition? Is composition commutative? So let's take a look at an example. This says if f of x equals x plus 1 and g of x equals 2x minus 5, show that f composed with g of x is not equal to g composed with f of x. So show that, at least in general, composition is not commutative. Now, Tomorrow, we're going to look at some examples where it is commutative, but those are specific cases. In general, it's not commutative, as we will see here. So f composed with g of x equals f of g of x. Okay? But g of x is 2x minus 5, so that's going to go there. So this would be f of 2x minus 5, and that is going to go there. So this is 2x minus 5 plus 1, which is 2x minus 4. So f composed with g of x equals 2x minus 4. Now, let's take g composed with f of x and see if we get the same answer. G composed with f of x equals g of f of x equals g of, well, let's see, f of x is x plus 1, and that would be 2 times x plus 1 minus 5, which is 2x plus 2 minus 5, which is 2x minus 3. So they aren't equal. Well, they're close. Close only counts in horseshoes and hand grenades. Okay, anyway, so in general, composition is not commutative. F composed with G in general does not equal G composed with F. But as I say, tomorrow we'll look at some cases where that is true. Any questions? All righty.
No.
No? Okay. Well, that's all I've got for today. So I'm going to go ahead and stop the recording.